Now the topic is finding duplicates in a string. Here is a string. We have to find out, are there any duplicate alphabets in a string. For example, in a given string, I is repeating more than one time, N is repeating more than one time. So we have to find out, are there any alphabets which are repeating more than one time. So this is same as finding duplicate elements in a array of integers, which we have already seen in the topic arrays. So the same thing, it is for string, that is alphabets we have to check. So there are more than one methods for finding duplicates. We have already seen multiple methods for finding duplicate numbers. Now we will see what are the methods for finding duplicate characters in a string. See, the first method is comparing with other letters. Then second one is using hash table or counting the letters. Then the third one is using bits. Now this method, the first method, is same as what we have learned in arrays, like taking a number and comparing with rest of the numbers in an array. So we will take an alphabet and compare with rest of the alphabets in an array. So the method is same. So I will not explain you in detail. You can refer back to the video finding duplicate elements in an array of integers. Then second method is also similar to the one we have already seen, but there is a little change here. So I will explain this one. Then the third one is the new one, that is using bits, that I will cover in next video. So let us start with the first method, comparing with other elements. Let us see comparing an alphabet with the rest of the alphabets. So the procedure is, we will start scanning the string from left hand side. Let us start from here. First, F. Now we have to check, is there any other F inside a string? If so, we have to count it. So we can take a help of J counter and start checking. Is it F? No. Next character, is it F? No. Is it F? No. Is it equal to this? No. Is this equal to this? No. Is it equal to this? No. We have reached the end. So we have scanned through the rest of the characters in a string. Then F is not found. Next we will move to the next character. Is it same as I? No. Is it same as I? This one? No. Is it same? Yes, it is found. So we found one duplicate. So as I already told you that we should remove this and make it as 0 so that it should not be counted once again. Right? Then check with this one. No. Check it with this one. No. We have reached the end. So we have found one more I. So there are two occurrences of I, this one and the another one that we found. So the similar procedure you can follow. You can check the video once again for finding duplicate elements in an array. Like this method I have shown you. So it's the same method. Only thing is here the alphabets are there and you have to stop when you are reaching null character. Right? And we have also done the analysis for that one. The time taken is order of n square, that is big O of n square. So the same thing, same analysis, same procedure, only these are alphabets. Right? So I don't want to elaborate this one. Now let us go to the second method, that is using hash table or counting the occurrences of alphabets. So let us look at hash table. For using hash table, we should have an array to work as an hash table. Now what should be the size of an array? That depends on the numbers that we are storing. So whatever the largest number that we are storing, we need an array of that much size. Yes. So let us see what we are actually going to store. See, we are going to store alphabets and these alphabets are having their ASCII codes. Yes. ASCII code. I have taken all these alphabets as lower cases, so they are in the range of lowercase alphabets. So we should know the ASCII code of all these alphabets. So let me write down ASCII codes. See, ASCII code of D is 100 and F is 102, G is 103, I is 105 and N is 110. These are the ASCII codes. So ASCII codes are more than 100, right? So if you know the range of lower cases, the lowercase range starts from 97 to 122. So it means I need an array up to the maximum length of 122 and I will be start using that array from 97 onwards. Means all the elements from 0 to 96 are useless. Why to create that much lengthy array when we know that the first letter lowercase a is 97 and lowercase z is 122? So why can't we call this as a 0, right? And the B as 1 and so on. So this will be 25. So 0 to 25, total 26. So it means an array of size 25 will be sufficient for us. Yes, array of 25 is sufficient. So this is how we can reduce the size of the hash table. We can take just of size 26, that is 0 to 25, and we can find out the counting of these alphabets and the duplicates alphabets, right? And mind it, this is only for lowercase alphabets. There are no uppercases. So let us draw a hash table and run the procedure and see how we can count them. So here I have an array for hash table, that is starting index is 0 and the ending index is 25. So I have an array of size 26. Now let us run the procedure and scan through the string. Now one more thing, this array, assume that it is filled with zeros, right? I did not fill it with 0 to make it just simple, to look simple. I have left them empty. Assume that are all zeros. Alright. Now let us scan through this string. First alphabet, F. ASCII code of F is 102, right? Minus 97 if we do. This is 5. So go to the index 5 and already it is 0, just increment it. So it is 1. Then move to the next alphabet, I. This is 105. So I is 105. Minus 97 if you do, then this will be 8. So go to index 8 and increment it. So already it was 0, just make it as 1, plus 1. Then next N. N ASCII code is 110, right? Subtract 97, so it is 13. Go to index 13 and increment it. Then move to the next alphabet, that is a D. D's ASCII code is 100. Minus 97 gives 3. Go to index 3 and increment it. Then next is I. I's ASCII code is 105. Minus 97, 8. Go to index 8 and increment. So this was already 1, so it will become 2. The next N. 13. Go to 13. It's already 1. Make it 2. Then next is G. G ASCII code is 103 minus 97. So this is 6. Go to index 6 and increment it. Then next is null. So that's all. We have finished the string. Now we have the counting of all the alphabets. See, first is representing 0. 0 means 0 plus 97, right? 0 plus 97, because we have subtracted 97. Now add 97 to this one. 97, A is 0 times. Then plus 1, 98. B is 0 times. C is also 0 time. D is 1 time. Likewise, we know the counting of each and every alphabet in a string. So if you want to know what is this one, so add 97 to this. 97 plus 8. So this is 103, and 103 is G. So that's how we can get back the alphabets, by adding 97 into the values in the hash table. Right? So this is how you can count. And if any number is more than 1 time, then there are duplicates. Alright? So let us write down a piece of code here to perform the same procedure and display only those alphabets which are appearing more than 1 time. Like I and N is appearing more than 1 time, let us display only those. So what all we have done, I will write on the same thing here. So first of all, I need a hash table H of size 26. And I need I also. Now using a for loop, I will scan through a string for I assign A of I is not equal to null character and I plus plus. Now for every alphabet, whatever its alphabet is, subtract 97 and store in the hash table. So in a hash table, at what index? Whatever A of I is, from that subtract 97 and add 1. So for that I will assign plus assign 1, or even I can say plus plus. So I'm incrementing it. So in a hash table at a given index, like for example, A of I is F. F is 102. This is 102. 102 minus 97. How much this is? 5. So this is 5. So this becomes what? H of 5. H of 5 is incremented by 1. So H of 5 plus 1. It becomes like this. So for every alphabet, it will be calculated in the same way, so the indices are obtained. So this is how the entire hash table array will be filled. Then next I should scan through this hash array and find out if any value is more than 1. If it is more than 1, then alphabet is repeating. So I'll continue writing. So this is the end of a string. We have scanned through a string. Now we have to scan through a hash table. Hash table starts from 0 and hash table end at 25. So less than 26 I can write here. Then I plus plus. Then what I have to do is, if at any place of h of I, if it is greater than 1, means there are more than one occurrences of an alphabet. So which alphabet? So I will print it, printf percentile C. I have to print the alphabet. So what I should do, suppose here it is more than 1, 8. So add 97. So it is 8 plus 97, it is 105, and 105 is I. So this I is repeating more than one time. So I have to add 97 for this index. So whatever the index I is, right now I is pointing here, right? So it is pointing here. So I plus 97, and also how many times it is printing appearing, I have to print that one also. So printf percentile D, I will print the number of times. So that is h of I gives you the number of times. This will be done only if the value at that hash table is greater than 1. So that's all. This is the procedure. So you can know the alphabets which are appearing more than one time. Duplicates you can find out. Now if we do the analysis, how much time it is taking? We are scanning through this string. So string is linear always. So let us say n. And again we are scanning through this hash table. So this is also linear. So this is also n. As I said that we don't check the sizes, we see that whether the behavior is linear or not. Like the number of alphabets here are total 7 and hash table size is 26. We don't say that these are different, right? We say that this is linear. So n, this is also linear, n. So this is 2n, 2 times linear. So 2 times linear is also linear. So the time is big O of n. Now this is a student exercise, so you have to write on this program and check it by yourself. There is no demonstration on this one, so you do it by yourself. And one more thing, I have shown only for lowercase alphabets. Now if there are uppercase also, right, or upper and lower cases are mixed, then you have to increase the size of hash table. You may have to take up to size 122, so you try for that one also. So that's all in this video. Now there is one more method, that is using bits, that I will explain you in next video.